So hi guys, hi, good evening. So hello guys. So we'll be starting with our class in 5 minutes. So we'll be starting sharply by 5 p.m. So yeah, so we'll be starting with a problem which we had left yesterday. Excuse me. So the problem is okay guys, cool. So there is 2 more minutes for class to start. So it's available. YouTube Live is available exactly by 5 p.m. Okay, it's not going to get started prior to that, though I start here. Yes. Okay, it started. Good. Okay, so we'll be yes, guys. Let me know if my voice is clear and if there's any change necessary for me to adjust. If let me know if my voice is clear, audible, and you are able to see my screen clearly. Yes. So hi guys, I'm Pradeep Kumar, your physics teacher for 12th. Hi. So hope everyone is doing great. Yes, guys. Hello. So yeah, we'll be starting with the class in 2 minutes. So it's 2 minutes more for 5. So let's wait till 2 minutes is done. So hi Bhargav, hi Lakshmi, hi Hima, YouTubers. Good evening. So waiting for others to join. So waiting for all the YouTube, all the Zoom audience to join. Okay. So waiting. Hi, good evening, guys. Hi, Hemant, Dhanush, Prakash, good evening. So, hello, good evening, YouTubers. Hope everyone is able to hear my voice clearly and are able to see my screen clearly. So, I'm launching the technical check, guys. Please check. Please go through. Go to the technical check. Please check if my voice is clear and my board is visible to you guys. Yes. Please let me know. Yeah, if there is any corrections need to be made, and guys, please try to be on time. Please try to be 5 minutes earlier to the class so that we can start the class exactly by 5 p.m. Otherwise, I need to wait for most of you guys to join, and yeah, if we start in the very beginning by 5, and if you guys join late, then you would miss the class, right? No, yes, this is an hectic day, but I mean, this is a lengthy day. I can't say it. Like it might be good for some. Yeah, it might be good for some, mad for some. But still, yeah. What I meant to say is, yeah, you should be on time or you should be earlier, bit earlier. Please don't annotate, guys. I think I had. Okay, I had removed the annotation. Students don't play with the YouTube. I mean, don't play with the Zoom. Everyone, it's a request, and yeah, we'll get to know who is doing this and would remove them from class. Please don't do this again. Don't repeat this and block the annotation. But I don't know how you guys got that. Yes, anyway. So let's begin our class. Okay. So we had started our class with, okay, we'll start our class. So the very first thing which we had left yesterday was this problem. So guys, did you guys try this? Did everyone try this? YouTubers, please try to respond. Guys, I request everyone to respond. And yeah, we need active participation in the class, guys. Come on. So if you can't do it, then who can do it? Active, be active, guys. Everyone try to respond. Okay, how many of you did try this, guys? How many of you tried this question? Did you try? Yes, cool. So yeah, we'll solve this question. Okay, we'll solve this question. So what was this question on? This question was on electric potential. So this was one question which was pending in our previous session. So this is on electric potential. So guys, please give your technical check so that I can be confirmed that everyone is able to hear my voice clearly and see the blackboard. I mean, see your screen properly. My screen is visible clearly. Yes. Yes, guys, come on. Okay, cool, guys. So I'm going to end the poll for your technical check. And yep. So we'll start with the question, okay? So the question, so guys, tell me, some equipotential surfaces are shown in this figure. So there are some equipotential surfaces. Say if this is the center, then there is, at 10 centimeters, I have an equipotential surface of 60 volts. At 20 centimeters, at 10 centimeters length, I have an equipotential surface of 60 volts. At 20 centimeters length, I have an equipotential surface of 30 volts. And at 30 centimeters length, I have an equipotential surface of 20 volts, right? Yes? Please reply with yes, no, something, yep. Guys, come on. Reply, please. Yep. Yes, cool. So these are the respective distances and respective potentials. Now what happens? So what do we know about potential, guys? What is the formula we know about potential and electric field? How to find electric field if we know the potential, or how to find electric field if we, yeah, how to find electric potential if we know the field? So what is the general relation we had? We had this relation, right? E is equals to or E dot R is equals to minus dV, right? Say we are going to find only the magnitude. So I'll take everything in the mod. So what I'll get, E dot R is equals to, okay, since this is V, okay, I'll take it as V only. Okay, yes, correct Namrata, correct Prajwal, yep. So this is one of the formula which we are going to use in this. And what is the other formula? What is electric potential, guys? What is the formula for potential? V. General formula for potential, electric potential. YouTubers, please try to reply. Try to be active, guys. Come on. Try to be active. Yes. 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 Correct, Namrata. It's K times Q by R. So this is the expression for electric potential. So we'll be using these two formulas, guys. One is electric field formula, other is electric potential formula. Okay, now guys, tell me what is my, we know that using this equation, I'll use this equation 1. I'll call this equation as equation 1 and this equation as equation 2. Okay, so using equation 1, what can I write? Can I write V is equals to K Q by R? From here, if I cross multiply, what would I get, guys? If I cross multiply, what would I get? I would get V into R, V dot R or V into R is equals to KQ, right? I would get V into R is equals to KQ. Now we know this is nothing but a constant. For equipotential surface, this is nothing but a constant. It's a constant value, correct, guys? My value of K is 9 into 10 power 9, and my charge, which is responsible for this equipotential surface, is also same throughout. Agreed? Yes. Guys, click on yes. Please be active. So if I don't get response, I can't give you properly. Yes, Danush. You raised your hand, Danush. Yes. Okay, cool, guys. Thank you. Now, so if we know V into V dot R or V into R is equals to KQ is a constant, so we'll be going to use this. Yes, Bhargav, correct. Correct, Ramakrishna Reddy, correct. Yeah, we'll be going to use this. Now try to find V dot R for each of the cases. Say if this is case 1, 2, and 3, find V into R for each of these cases. Guys, tell me what is V dot R or V into R for each case. So for case 1, first case, so my distance R is 10 centimeters and potential V is 60 centimeters, 60 volts, right? Yeah, 60 volts. What is VR? What is V dot R? You know V dot R is a constant. So what is its value? So let's verify that. VR is equals to, guys, tell me, help me solve this, please. Help me solve this, please. What is V into R? Reply in the chat box. So my V is 60 and R is 10 into 10 power minus 2. So this is 6, right? This is 6. So check for the second case, guys. What is second case? What is my second case? What is my second case? For VR, R is equals to 20 centimeters and V is equals to 30 volts, right? Even in this case, what is my VR? 30 into 2. So 30 into 20 into 10 power minus 2. That is again 3 into 2, 6. So again 6, right? Rajwal, please check. 3 into 2, it's 20 centimeters, not 10 centimeters. Okay, I'll change my color for each of these. Okay, I'll change this color completely. Can try to change its color. This is my second equation. So for third one, we'll take a different color. For third case, what's happening? Third case, R is 30 centimeters and potential is 20 volts, right? Yeah. In this case, what is the value of VR? Is 30, again 30 centimeters into 20 volts. So 30 into 10 power minus 2, yeah, this is for centimeters and 20 volts. Again, my value of VR is 6. Guys, in our previous slide, we took VR is equals to KQ, right? You know that from this, okay, I'll call this equation 3. I'll call this equation 3, okay? Okay, from equation 3, we know that VR is equals to KQ, right? VR is equals to KQ. So then my value of K and Q will be, yes, correct, Ramakrishna Reddy, correct, Krish, correct. Yes, correct, Bhargav. Yes. So from here, what is my electric field formula? We know we'll be using from equation 1. We'll be using equation 1 here. Okay, I'll use a different color for this. Yes, yes. use green color. From equation 1. What is equation 1, guys? What is my equation 1? E is equals to KQ by R square. Do we know that? Oh, again. Or, so okay, it's not from equation 1. Say, we know that. What is E, guys? What is E? Electric field E is equals to F by Q, right? F by Q. Yes, correct, Ramakrishna reduce. Correct, Bhargav. So we know E is equals to F by Q. What is F? F is K times of Q1, Q2 divided by R square. Right, F is K Q1, Q2 by R square divided by small charge, test charge Q. From here, these two are cancels. So I get electric field E is equals to KQ by R square, right? Guys, please reply. So let me know if I'm going fast. Let me know if I'm going fast. Or yeah, got this. Please reply. From here, what is my electric field, guys? Tell me the answer. From here, what is my electric field? So I know VR is equals to KQ. From equation 3, we know VR is equals to KQ. From E is equals to F by Q, I know the value for electric field or the expression for electric field is KQ by R square. So I know if I want to substitute the values, what is my electric field, guys? What will I get as electric field? Yes, correct, Bhargav. Guys, reply. Reply, please. Okay, super YouTubers. YouTubers be active like this. Thank you. And Zoom audience, please try to answer this. Guys, substitute the value of E. Yes, correct, Krish. Correct, Krish Modi. Awesome. Yes, correct, Danush. Awesome, guys. So my value of KQ, this is nothing but my value of KQ, that is 6 in all cases. This is KQ. So my electric field expression for magnitude of electric field will be KQ by R, that is nothing but 6 R square. That is nothing but 6 by R square. So this is my magnitude of electric field. This is the magnitude of electric field which I get. Yes, guys. Omega, please check your answer. Correct, Lakshmi. So correct, Ramakrishna. Yes, correct, Ramakrishna. Cool, awesome. So yeah, yes, even from equation 1 we can get that, right? Yes, from equation 1 E is equals to V by R. So V is nothing but my KQ by, okay, this cannot be KQ by R, right? V is equals to KQ by R into R. So yes, we'll get E is equals to KQ by R square, that is 6 by R square. This is the magnitude of electric field. Now guys, what is the direction of electric field? So they are asking what is the direction of electric field? What is the direction of electric field? Direction of electric field. Is it from inwards to outwards or outwards to inwards? My direction of electric field, is it from in to out or out to in? Yes, my electric field is always coming, always in the direction of the electric potential, which is dropping the fastest. So my electric potential is dropping outwards from inwards. So my electric field will be always in a direction from inwards to outwards. Correct, Bhargav. Correct, Anusha, Prakash, Namrata. Thank you. Thanks for the answer. Cool, guys. So got this question, guys. Yesterday we were in a bit of confusion or yeah, something happened with this question. So we were not able to solve this yesterday. So we have solved this today. Okay, cleared with this question, please click on S, guys. If you're cleared with this question, please click on S. Yes, thank you. So guys, hope everyone is revising. Yes, correct, Modi. Correct, Krish. Correct, Ramakrishna. Cool, guys. Then, okay, I hope everyone is revising every day. So what I'll do is I'll quickly launch a poll for you guys. So everyone in Zoom can take all 5 questions at a time. Everyone in YouTube, please take all questions. Try to write the answers for all questions. Say everyone in YouTube can reply me in the chat as 1 and option, 2 and option. Please make that. all of you are going to answer these questions at the same time, all 5 questions at the same time. Okay, guys, please take this question. I mean, take this recall test, everyone. Hope everyone have learned, understood all the questions yesterday. I mean, hope everyone had understood all the concepts which we had taught yesterday. Yes. If you have understood all the questions, then try to answer this question. I mean, if you have understood all the concepts, try to answer these questions. So everyone are supposed to answer these questions all together at the same time. Okay. Thank you. Cool. So let me know how much you guys know the answer, or how much you guys have learned in yesterday's class, right? So it's just a small 5 questions concept test. This is also called as the recall test or spot test in our pedagogy. So we'll be learning this. I mean, it will help us to know if if the students are revising daily, right? Yeah. So guys, hope everyone have done. Okay, have received only one set of answers so far. Hmm. Okay, okay. Ramakrishna Reddy had answered. Ramakrishna Reddy, there were 5 questions, bro. Please check. Uh, Ramakrishna Reddy, there are 5 questions. You answered for 4 questions. Oh, sorry, you answered for 3 questions. Okay, cool. Yes, correct, guys. So most of you. So I'll discuss the answers in the YouTube, guys. So YouTube, guys, I'll discuss the answers in this recall test. Please wait, everyone. Yeah, everyone. To everyone, I'll discuss the answers once everyone have completed the voting. So guys, please. I'm going to end this poll in 1 minute. So I'm going to end this poll in 1 minute to everyone. Please vote. Answer your. Okay, answer these questions fast, as quick as possible. Yes, cool, Krish. So guys, everyone could check out. Everyone could check out how much you have scored. I mean, how much you have answered correct. Once I stop the poll here, I'll be starting to discuss the questions. Okay. So guys, I have given you 1 more minute time to everyone. Please solve these questions. Should not take more time, guys. 1 minute. Wow. So none of these questions have D options, guys, but yet I got D option too. How is this possible? That's amazing. So hope everyone is able to see all 5 questions. Is there any difficulty in understanding or watching any of the questions? Please let me know. Okay, guys, let's discuss. So I'm going to end the poll, guys. Thanks for participation. Then I'm going to end the poll. Yes. Okay, I end the poll. Okay, cool, guys. So I have received the answers for these questions. As you could see here, these are the answers which you guys have given me. Okay, so I'll discuss the question answers, guys. Come on, help me solve this. So dipole moment is a scalar quantity, true or false? Is dipole moment a scalar quantity? How many of you said true? Click on S. How many of you said true? Click on S. Dipole moment. What is dipole moment, guys? Yes, correct, guys. So yep. So most of you had answered it A. Some of you had answered B too. So some of you had answered A. So dipole moment P is equals to Q times of 2 into A. So guys, whenever we represent dipole moment, always I represent P with a cap arrow, right? What does this arrow signify? It signifies the dipole moment. Dipole moment is a vector quantity, right? It's a vector quantity. So it has direction. From which direction to which direction in physics, guys? My dipole moment is always from negative charge to positive charge. My dipole moment always acts in the direction of negative charge to positive charge. What is the dipole moment magnitude? Magnitude of dipole moment is, yes, correct, guys. Cool, awesome. So q times of 2a, where 2a is the fixed distance. It's the displacement vector, right? Hope everyone remembers this. So the first answer is B, option B. Everyone who had clicked on, who had checked with A, please correct yourself. It's B. First answer is B. And dipole moment is a vector quantity, so answer is false for first question. So dipole moment is a scalar quantity is the wrong answer. Dipole moment is a vector quantity. Remember this, guys. So second question, guys. So SI unit of dipole moment is, yes, awesome, guys. Come on, answer. So SI unit of dipole moment is coulomb meter. So coulomb meter is the correct answer, right? So where Q, if you could see this expression, P is equals to Q times of 2A, the SI unit of Q is coulomb and SI unit of P is meter. So it's a meters. So coulomb meter is the SI unit for the dipole moment. Next, guys, the separation between the charges in an ideal dipole is very, very small, guys. So the separation between the charges in an ideal dipole is very small. Okay. So third question, an electric dipole can have a non-zero net charge. Yes. So there was a slight, guys. Yes, is my yeah, is my voice audible to you, guys? There was some error and there is some problem with the network, guys. Is my voice audible? So there is a break in my voice. Okay, is it audible now? Is my voice audible now? Okay, I'm trying to connect. Yes, cool. So my voice is clear now, right? Yeah, thank you. Thanks for the response, guys. So the electric dipole can have a non-zero net charge. Yes. Can dipole have non-zero net charge? Yes, true. So we saw that in the case of HCl, but guys, also what's a dipole? What's a dipole? The structure of dipole, guys. What is the basic definition of structure of dipole? So what should I conclude with this? Is it true or false? The structure of non-zero dipole, non-zero net. Okay, can dipole have a non-zero net charge? See, dipole are, so the structure of dipole says it should have two charges of same magnitude separated by distance of 2a. Now, the net charge on each of the dipole. So, one is having a positive charge, one is having a negative charge. What can the net charge? The electric dipole, can an electric dipole have a non-zero net charge? Yes or no? So, by definition, a dipole is, yes, both the poles are having. Yep. So Prajwal, okay, okay, cool, Ramakrishna Reddy. So Prajwal, how can this have? I'm asking, like, how can these two charges? How can it has a net positive charge? Yes, if one is bigger or one is smaller, right? So ideal. So they did not mention, guys, in an electric dipole. Yes, yesterday we learned it depends on the situation. For this question, it should have two conditions. So if it's an ideal dipole means it has same magnitude separated by a distance 2a. Okay. Otherwise, if it's a in chemistry, you have dipoles, right? With HCl, say in the HCl. So in that condition, we had, yeah, one big charge and one small charge. In that case, we can have non-zero net charge. But in physics, we are discussing only the dipoles with two magnitudes having same, two charges having same magnitude. So in physics, we'll consider it as false. Okay. In physics, we'll consider it's false because it's having same magnitude. Okay, it depends on the situation, guys. Again, yes, it depends on the situation. but yet I'm going to give it as false. Okay. Yes, H was, yeah, in case of chemistry, yes, we learned this. H was having a slight positive charge and Cl was having a slight negative charge. Yes, this exists. But in physics, what we consider? We consider two charges of same magnitude separated by a constant distance, a fixed distance. Since my charges having same magnitude and opposite direction, will be taking its net charge as zero. Okay. Any doubts, guys? So in physics, we'll be considering it as zero. Okay. Any doubts? Any doubts in this question? No. Okay, cool. I will continue. Then the electric monopoles can exist independently. So guys, what is an electric monopole? What do you mean by an electric monopole? What do you think an electric monopole be? Yes, hi, Hari Prasad. Good evening. So what's an electric monopole, guys? So monopole is a single charge. Okay, it's a single charge. So dipole is, yes, correct, guys. Correct, Samrat. Correct, Prajwal. Yes, monopole is a single charge. In dipole, we had two charges, right? One positive charge and one negative charge. A monopole is a single charge. So guys, this same concepts will be repeated again to you guys about the dipoles and monopoles, or about the dipoles in your magnetism. So in case of a magnet, a monopole is not possible. But in case of an electric charge, yes, a monopole exists. It means a single charge. A single charge exists. Correct, Krish? Yes, having only one charge is, or a single charge is monopole, or electric monopole means a single charge. Yes, it exists. So monopoles exist for electric, or electric monopoles exist in nature. Okay. So how many of you got 5 out of 5, guys? Come on, tell me. So how many of you got all 5 correct? Is there anyone? Okay, cool. So if anyone have got all 5 correct, then awesome, guys. So even if you have got more than 3, then superb. Anyone who have got more than 3 is awesome. Okay, cool. Nice, guys. It's great. Okay, so we'll have a quick revision of what we learned yesterday. So guys, please help me revise. So what are the options? Say, yeah, what we studied in yesterday's class? We started with electric dipole, right? What is an electric dipole, guys? What is an electric dipole? So an electric dipole, structure of electric dipole. Tell me. Come on, guys. I want you to answer. What is an electric dipole? So electric dipole consists of a positive charge and a negative charge. So what was structure of dipole? It consists of two charges, yes, with same magnitude. So two charges with same magnitude. So both were Q, and one was having a positive charge. So I'll take this as positive, and the other one was having a negative charge, say a negative charge. Now these two positive and negative charges were separated by a fixed distance. What was that distance? It was separated by a fixed distance of 2a from center. Okay, it is always from center. This fixed distance is from the center of these two charges. Yes, separated by 2a, and c was the midpoint. Okay, then there existed a dipole moment between these two, given by vector p. This dipole moment was given by vector p. What is the okay, this is called as the dipole moment, right? Dipole moment. This setup together, it's called as a dipole, an ideal dipole. So yes, guys, yeah, the line joining this center, I mean the line joining these two dipoles is called as an axis. Okay, the line joining these two dipoles or these two poles is called as an axis. Yeah, in physics it doesn't have, Hariprasad. Yeah, in physics we'll consider the dipoles are ideal, having same magnitude but opposite in charge. Okay, we don't discuss chemistry here. In chemistry we'll be having different condition. Okay, so there are. So yep, next guys, what is dipole moment? Magnitude of dipole moment. Tell me fast, what is the magnitude of dipole moment? What is the magnitude of dipole moment? Yes, P is equals to, the magnitude of dipole moment is given by P is equals to Q times of 2A. Okay, P equals q times of 2a. If you want to take magnitude, take mod on both sides. What is the direction? Direction is from minus q to plus q. It's opposite. Okay, cool. This is what we studied yesterday. And in case of yeah, we learned also we segregated, we divided this in case of physics and chemistry. So in physics it's from minus q to plus q. My dipole moment is from minus q to plus q. In chemistry it's from plus q to minus q, right? Right? Yes, correct, Bhargav, correct, Ramakrishna, correct, Hari Prasad. Cool. Awesome, guys. Come on. Let's keep the class active. So let's keep it very, very active. Okay. So this is what we learned. For physics, it was my dipole moment was from minus q to plus q, whereas for chemistry, it was from plus q to minus q. So in chemistry, it shows the moment of electrons from an electrophobic to an electrophilic, right? Electron hater to electron lover atom. So we learned that in with the help of HCl atom, right? So one electron from hydrogen was shared with chlorine. So this chlorine, what it did, it pulled the electron towards itself, creating a net positive charge on hydrogen and a net negative charge on a slight positive charge on hydrogen and slight negative charge on chlorine. So this is what we studied yesterday, and we solved a problem based on the dipole moment. In today's class, we'll again try to find a okay. Hope everyone have understood this so far, whatever we had discussed. Guys, hope everyone remembers this. Yes, any doubts in this? Okay, cool. So let's try to solve a question based on that dipole moment. Okay, please try to solve this question and I'll launch the poll for you guys. Please try to answer this. So what's given in this? A system of two charges, say QA is equals to 2.5 into 10 power minus 7 and QB is equals to minus 2.5 into 10 power minus 7 coulombs are located at points A. Okay, so I'll directly write the points. So at what is the distance from A? A is at minus 15 centimeters K cap. Okay, and what is point B? P is plus 15 centimeters K cap. These two are in Z axis. Okay, these two are in Z axis. Okay, what are the total charge and electric dipole moment of the system? So just tell me what is the electric, what are the total charge? What are total charges, guys, in this case? What is the total charge? Tell me in the chat box and find the dipole moment and answer it in the poll. Okay. Find the dipole moment and answer it in the poll. Oh, oh my God. Cool, guys, cool. So what is the total charge and what is the total, what are the total charge and electric dipole moment of the system? Okay, total charge, net charge is 0, correct? Yes, guys, cool, awesome. So everyone have replied. Correct, Ramakrishna Reddy. Correct, Danush. Others, please try to reply. Guys, please try to reply me. So what is the net charge? They are asking what is the net charge. Net charge. Q net ಏನಾಗುತ್ತೆ? Q net will be equals to QA plus QB. This will be equals to obviously 0. So everyone got this answer. What are the total charge or net charge is 0. Then what is its dipole moment? Try to find its dipole moment, guys. What is dipole moment formula? Hope everyone remembers what is dipole moment formula. P is equals to Q times of 2A. So guys, what was this Q? What was this Q? I said Q is the positive magnitude. Yes, always. Q is the magnitude of any one of the charge. It's the magnitude of any one of the charge. Okay. So it's always positive. Please take it as positive. Please take Q as positive, everyone. Yes, whoever asked this, who asked this? Yep. Yes, correct, Ramakrishna Reddy. Awesome. Ramakrishna Reddy, you have given the correct answer. Krish Modi, correct answer. Superb. Super guys, you are awesome. So guys, please try to answer here. Yes, Dhanush. I hope got the answer. Cool. So correct, guys. Most of you have got the answer. Please try to reply as much as possible, guys. I mean, no, you have to reply not as much as possible. You should reply. Do reply. If you even if your answer is wrong, it's fine, but reply. Okay, everyone here in YouTube, I mean here in Zoom, please click your answer in your polls, which is launched to you guys, and answer the question. Is correct, Radhika? Correct. Whoever Mega, I think Mega sent this. Radhika correct. Lakshmi correct. Lakshmi Kita correct. Cool. Rajwal correct. Anusha correct. Okay, guys. So shall I end the poll? I'll end the poll. No, it's been a long time. It's been a long time since we have launched the poll. Okay, I'm going to end the poll, guys. Then yes. Okay, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, I have in the poll. So yes, most of you have given me the right answer, guys. Awesome. This is awesome. So just guys try to substitute the values. That's all. You will get the answer now. So what is my Q? My P. Okay, this is in the direction of P cap, right? So what is P cap? You have to find what is P cap 2. Okay. So what is the value of Q, guys? My value of Q. So my value of Q is 2.5 into 10 power minus 7 coulombs into what is my 2A distance, guys? So what is the distance between minus 15 centimeters to plus 15 centimeters in number line? Say if I have a number line, so this was said to be the plus Z axis and the minus Z axis. So if this is positive 15 centimeters, so if I consider, yeah, I'll consider a origin. So if this is my origin, this is my positive 15 centimeters, and I have my negative 15 centimeters over here. What's the total distance between these two guys? Okay, if this distance is A, if my distance A is 15 centimeters, what is 2 times of A? 2A, right? It was 2A. So how much is that? Please reply, guys, everyone. Yes, 30 centimeters. Cool. So this is 30 centimeters. I'm converting 30 centimeters into meters, 30 into 10 power minus 2. So try to solve this, guys. What is P? Value of P you get? 3 5 is 15. 3 to the 6, 7.5 into 10 power minus 8, right? So there is 30. 10 into, so 10 power 7 plus 2 is 9, minus 1 is 8. So I get 7.5 into 10 power minus 8. Okay, 10 power minus 8. In which direction, guys? Now tell me. In which direction? What is the direction? Yes. So yes, it's in along the minus k cap direction. Okay, from along the minus k cap direction. So this is, so this negative goes here. So option B will be my correct answer. Okay. Yes. So how did we get minus? So my dipole direction, my movement of dipole is always opposite from my negative to positive, right? My dipole movement is from minus q cap, minus q direction to positive q direction. So it's minus p cap in this case. So yes, this is the answer. Okay, cool, guys. So my answer is minus 7.5 into 10 power minus 8 k cap centimeters. So guys, okay, hope everyone have understood this and solved this. Yes, please click on yes if you have done this. Please click on yes. Yes, cool. I have the next question for you guys. Please try to solve this question. This is again on the dipole moment. So this is again on the dipole moment. So your time starts now. Please try to take minimal time, guys. Try to take less than 3 minutes, less than 3 minutes, less than 3 minutes for this question. So this is one interesting question. So it should not take more. It should not take even 3 minutes. Okay, let's keep less than 2 minutes then. Try to solve this question, guys. Come on. There are three charges arranged at the vertices of an equilateral triangle as shown in the figure. So there is one charge of minus q magnitude, another charge of minus q magnitude, and another charge of plus 2q magnitude on three vertices of a triangle, on three edges of a triangle. So whatever. Then these triangle, the length of this triangle is d. One side length of the triangle is d. Now, guys, tell me one thing. What is the angle of an equilateral triangle? What is the angle of an equilateral triangle? I hope this is taught to you guys in your math. Yes, correct, Samrat. Yes, correct, guys. Awesome, awesome. Cool, cool, cool. So the angle of this equilateral triangle is 60 degree in all cases, right? In all cases, it says 60 degree. Then, guys, yes, try to find the magnitude of dipole moment of the combination. So how can we find the dipole moment of this combination, guys? How can we find? So it's a vector, right? We have solved many vectors. Find the dipole moment for two cases, considering two charges at a time. Find the dipole moment for each, considering two charges at a time. Then find its resultant. Try to find its resultant. Okay. So you have to find a dipole moment between two charges, two pairs of charges, and try to find its resultant. Okay, you'll get dipole moment in two directions. Try to find its resultant. Hope you got how to solve this. Guys, if anyone have solved, I hope, yep. Let me know if anyone have solved. Okay, cool, awesome. I have got four answers already. Cool, awesome, guys, super. Correct, Tejas. Please mention the answer. Okay, Lakshmi, if you are answering for this triangle question, are you answering for this triangle question? Yes. So, Lakshmi, check your answer, please. Lakshmi, please check your answer. YouTuber. Others, guys, try to solve this question now. So all other students, please try to solve this answer, solve this question. So guys, I'll give you a quick hint if anyone is not able to solve. So the hint is, see, try to split this q. So we have this 2q, right? Try to put one q here on one q on the other side. So we'll try to split this q as q and q on the same spot. Okay, again. So we'll take the dipole moment for these two charges as q and q. So why are we doing this? See, guys, a dipole is the one which has the same magnitude but opposite in sign, right? Dipole is one which has same magnitude and opposite in sign. So what I'll do, I'll segregate this 2q as q and q. Okay, so I'll consider these two charges once to find the dipole moment at this direction, in this direction, and I'll try to find these two charges. I'll consider these two charges once to find the dipole moment at this direction, and we can find the net dipole moment with, yeah, as a resultant of these two. Okay, correct, Bhargav Ratnala, your answer is right. Yes, guys, cool. So I hope I have given you a hint how to solve this question, guys. Try to solve this. So this kind of questions you can expect. Okay, this is an easy level question again. Okay, if not, okay, this is a medium level question for you guys. Yes, the only trick here is you have to split the 2q charge as q and q, as two separate charges of q magnitude of q. Okay. Okay, what is the formula for dipole moment, guys? What is the formula for dipole moment? P is equals to q times of 2a, right? The distance between the two charges is given as d. It's d in both the cases, right? then find the answer, guys. Come on. So it's taking more than 5 minutes, guys. I'm going to end the poll and let's discuss the question. So I want everyone, please, guys, I'm requesting everyone to participate in the class. If you're not getting, please ask me. Should not take more than 2 minutes or 3 minutes for this question, guys. Come on. I asked you to take less than 2 minutes. Okay. So yeah, majority of you have answered, and 5, 6, 7, 8, 9. Only 9 out of 25 plus students have answered. This is, please try to answer. No? Okay. So yes, guys, most of you have answered A, and answered option A is the correct answer. So let's try to solve the question. Okay. So what's given here? What's given here in this case? We are given with a triangle, equilateral triangle of side length D. So if Q is the charge on this vertex and this vertex, so no, sorry, minus Q, right? I'll consider this as minus Q. Okay, this is minus Q given, and there was 2Q. So I have to split this 2Q as Q comma Q. So I'll consider these two as Q comma Q, and I'll try to find, okay, I'll give a name to this A. I'll call this as A. I'll try to give name to these vertices as A, B, and C. Okay, A, B, and C. So what is the dipole moment? Dipole moment along AB. Guys, P along AB. What is the dipole moment along AB? Tell me. Come on, guys. Please try to tell me. Please try to answer. What is P along AB? No. What is P dipole moment is Q times of 2A, right? P is equals to Q times of 2A. What is my 2A value here? What is my 2A value here? Yes, correct, Namrata. So my 2A value is D. So Q times of 2A will be Q into D, right? PA will be PAB will be Q into D. Similarly, what happens with my PAC? Dipole moment along AC direction, guys. What is the dipole moment along AC direction? It is PAC equals to Q times of D. Again, it's Q into D. Okay. Again, it's Q into D. Right? Yes. Now, so I got one in this direction. I got PAB. Sorry. Yeah. PA. Okay. Should I call it PBC then? Okay, I'll call this B, then this C. Okay, this should work. PAB will be this, and P. Okay, whatever. Oh, I have to redraw. Guys, something happened. So if I consider this as B and C, yes. Okay, if this is my PBC, I'll call this PBC, and this is my PAC. Then my net dipole moment, guys. What will be my net dipole moment? P net will be. So we should use which formula? Resultant formula. So guys, I hope everyone remembers resultant formula. Resultant of two vectors. If I have two vectors, vector A and vector B, going in this direction, then by vectors law of parallelogram law of addition, or yeah, polygon law of addition, what is R? What is my R, guys? R will be given as square root of A square plus B square plus 2AB cos of theta, where theta is the angle between A and B. So it's the angle between A and B, guys. So please try to apply this resultant and find this answer. So if we are going to find P net or P resultant, then we get square root of, what is my A? PAB will be, so this is my A. If I consider this as A and this as B, then I'll get QD whole square plus QD whole square plus 2 into QD, yes, QD times of QD. Again, I'll write QD into QD, okay? Don't write QD square, I'll write QD into QD. Then what is cos theta? So cos of, what is theta, guys? Theta is 60 degree. So try to simplify, please. Guys, help me simplify this. Yes, thank you. Everyone, please try to simplify this. Yeah, if you take components also, it's easy. Yeah. Yes, Bhargav. So it depends, guys. So if you are going to take its components along x-axis and y-axis, what happens? All its one of the components of y-axis or x-axis will cancel out, and only one would remain. Then you will get the same value. Okay. So it's of no not different. It's same. It would be same. Okay, guys, come on, tell me it's qd square plus qd square. Try to simplify this and give me the answer, guys. Qd square plus qd square plus 2qd square. See, again, I'll try to simplify qd square plus qd square plus 2 into qd square. What is cos 60, guys? What is the value of cos 60? Yes, yes, correct, Summer. You could resolve this. Yes, guys, you can resolve these so that one of your sine or cos components would cancel, and you could solve that way also. Yes, cos theta is 1 by 2, cos 60 is 1 by 2. From here, 2 cancels. So what I get? I get my P net as P net or net electric field as square root of 3 times of QD square. Yes, from here, if I, what is my QD, guys? Again, what is my QD? Q into D. P is my Q into D, right? From, I know my QD is nothing but P. This is nothing but P, dipole moment, right? So from here, what I get? P net will be equals to root 3 times of P. Okay. So this is the expression, I mean, this is the answer which I get. Yes, hope everyone got this. So most of you have got this answer. So my correct option is option A. My answer is option A. Guys, any doubts in this question, guys? Any doubts in this question? Okay, no doubts. So hope you are understanding this. Then guys, come on, let's start with next concept. That is, we'll go with polar and non-polar dipoles. Guys, now tell me, what is a polar dipole? Yes, correct. Lakshmi, Bhargav, Ramakrishna. I hope everyone have understood the question, and yeah, all of you, yeah, you have participated. Yes, cool. Yes. Okay, come on, guys. Now tell me, what do you know about polar and non-polar dipoles? Is this chapter? I mean, the dipoles in chemistry. Have you completed this, guys? I think it was in your 11th, right? Was it in your 11th or 12th? So the concept of dipole, was it in 11th or 12th in chemistry? Okay, 11th. So it's already done for you guys, right? Now, what do you think? What do you mean by a polar dipole? What do you think a polar dipole is? Yes. Say, in the case of polar dipole, we'll discuss, okay? Anyway, we'll discuss that. In polar dipole, say it has two atoms or two charges with same magnitude, but the charges will remain always same. The net dipole moment always exists. The net dipole moment always exists in a polar dipole. So we'll study that with the example of a water molecule. So guys, water molecule is nothing but H2O, right? One H or one oxygen molecule is combined with two hydrogen molecules to get an oxygen molecule. Correct? Guys, yes. Right? So there exists a dipole. I mean, does there exist dipole? So I hope guys you guys are aware of valence and valency. So how many valence electrons are existing in the outermost shell of oxygen, outermost shell of hydrogen? I hope you guys know very well, right? Please reply if you know this, I mean, the valence and valency concept properly in your chemistry. Yes. Now, guys, then please help me solve. So I had been teaching physics, right? I don't have much of idea of chemistry. Now tell me, with the laws which we had studied for physics, using physics laws only. Okay. Don't use much of chemistry. Uh, Forget that. It's not physics class. Same. Okay. Now, which is more electrophilic, guys? Tell me this. Among hydrogen and oxygen, which do you think is more electrophilic? Okay, oxygen has 6 valence electrons, and it has valency for 2. Okay. Thanks for the information, Varga. So I'll write it down. I'll note it down. valency of oxygen is 2, and valence electrons in oxygen is no, okay, it's a single molecule of O, 1. No, sorry, 6, right? Valence electrons available in oxygen is 6. Excuse me. Similarly, the valence electrons or valence orbitals or valency, I'll call it valency of hydrogen is 1, and valence electrons available in hydrogen is also 1, right? So what happens, guys? So which is more electrophilic? Which is more electrophilic? Which is more electrophilic? Hydrogen or oxygen? Yes, correct, guys. Oxygen is more electrophilic, so it attracts all the electrons. Yes, thank you, Bhargav. Thank you, Lakshmi, for response. Thank you, Hima, for response. Yes. So what happens now? Since okay, I'll try to draw that also. Okay, now 1, 2, 3, 4, 5, 6. So it requires more 2, and hydrogen has 1 and 1. Right. Now what happens? So this tries to share its electrons. Right. This hydrogen atom shares its electrons to the oxygen. So there exists a covalent. Is it a covalent bond again? Yeah, sharing is caring is covalent bond, right? Please correct me if I'm wrong. Sharing is caring is covalent bond, right? Yes, cool. So what happens? This hydrogen donates, I mean, gives its electron to the high oxygen, and this hydrogen also gives its electron to the oxygen. So these two share an electron. So these two share an electron with the oxygen atom. Now, this oxygen, this electron which is being shared with oxygen, is more closer. Excuse me. Shall represent these shared electrons in blue color, guys. Blue represents shared electrons. Okay, shared electrons is represented in blue color. So these electrons which are shared with the hydrogen and oxygen, so these electrons which are shared with the hydrogen and oxygen is pulled closely towards oxygen than hydrogen, right? It's pulled towards closer to the oxygen than hydrogen. Now what happens here? Now tell me, guys, tell me what happens when it's being pulled away. I mean, when these electrons are being pulled away, what happens here? What charge would my hydrogen get? What charge would my hydrogen get, and what charge would my oxygen get? So my hydrogen would get a slight positive charge since it's losing an electron to oxygen. It's not completely losing, guys. Here it's just sharing, but the electron is moving away from hydrogen. My electron is moving away from hydrogen. So my hydrogen gets a slight positive charge. Since my electrons are closer to oxygen, my oxygen gets slight negative charge. Okay, represent this with a different color. My oxygen will get slight negative charge from two hydrogen molecules. So can I write this as 2 del? Can I write it as 2 del minus? Yes, can I write it as 2 del minus? Yes, partial negative charge on oxygen, partial positive charge on hydrogens. Yes, partial positive on hydrogens and partial negative on oxygen, right? So can I write this two combinedly as 2 del minus charges? So it since it takes 2, yes, thanks. Thank you, guys. Thanks for the permission. Now I'm going to erase this since this space is required. So I'll try to write the valency of oxygen is 2, and valence electrons in oxygen is 6. Right? Yeah. Now what can we say about okay, the molecule has light. Okay, now what can we say about the dipole moment, guys? My dipole moment, what in what direction is my dipole moment? So the molecule of oxygen has slight positive I mean oxygen has slight negative charge, and my molecule or the in the molecule, my hydrogen atoms have slight positive charge and my oxygen has slight negative charge, right? Now, in which direction is my dipole moment existing? In which direction is my dipole moment existing in physics, guys? I should be very, very precise, or I should be very, very clear. It's we apply only physics here. So what is the direction? What is the direction of my dipole moment? Tell me, guys. What is the direction of my dipole moment? From oxygen to hydrogen or hydrogen to oxygen? Tell me that. My dipole moment in physics should be applied from oxygen to hydrogen or hydrogen to oxygen. Yes, correct, Bhargav. Correct, Samarth. So, I should draw my dipole moment P in this direction. Okay. So, my dipole moment P is in this direction. Now, guys, there are two dipole moments for two oxygen hydrogen pairs, right? For one, for oxygen hydrogen pairs, there exist two pairs of oxygen hydrogen. So, or sorry, for one oxygen, there exist two hydrogens atoms. So, for each hydrogen atom, there exists a dipole moment. Correct. For each hydrogen atom, there exists a dipole moment. Then, where is my net dipole moment, guys? What can I say about my net dipole moment? My net dipole moment will be acting downwards, right? My net dipole moment will be acting downwards. Now, what about this net dipole moment, guys? Does this, now my question is, can you see this? Okay, my question is, does the net dipole moment, P net, is always there or not? Is my net dipole moment always present in case of oxygen, in case of H2O molecule? Yes or no? Yes, my net dipole moment is always downwards. Yes, there exists a net dipole moment. Yes, there exists a net dipole moment always acting downwards. So there exists a permanent. So what can I say? There exists a permanent dipole moment, right? There exists a permanent dipole moment in case of water molecule. Say it's in case of H2O molecule, there exists a dipole moment always acting downwards, right? So this sort of dipole moment or this sort of molecules exhibit permanent dipole moment. This sort of molecules are called as the polar dipoles. Okay, this sort of molecules are called as the polar dipoles. Clear, guys? What is polar dipoles? Are you guys clear with what is dipole, polar dipole? What is polar dipoles? So let's revise. So the polar dipoles, say in case of H2O, we consider, say there is partial negative charge on oxygen, partial positive charge on hydrogens. Now the net dipole moment is acting downwards, and this net dipole moment is always present in such the molecules in where the net dipole moment is always present is called as a permanent dipole moment or the dipolar dipoles. These dipoles are called as the polar dipoles. Okay, guys. Then, what do you mean by non-polar dipoles? Yes, if you understood that, what do you think? What do you think are non-polar dipole? Or what is non-polar dipole moment? Or what do you think objects which are atoms or any materials which are non-polar? What are non-polar dipoles? So, yes, temporary dipole moment. Yes, correct, Prajwal. Cool. So, we'll study about the non-polar dipole moment with the help of carbon dioxide. Okay. So, the non-polar dipole moment means a temporary dipole moment. Here, I have so two oxygen atoms. I have two oxygen atoms. So, this is an oxygen atom. So, I have two oxygen atoms, O2. Oh, so I have two oxygen atoms and one carbon atom in the middle. So I have one carbon atom in the middle and two oxygen atoms connected with a double bond, right? There exists a double bond. Now, so guys, again, my carbon, you know the valence and valency, right? You know the valence and valency. My oxygen requires two electrons to complete its octet. Is it? No, no, no. In this case, it's different. right? In this case, it's different. How many electrons does my oxygen require to complete its octet structure, guys? Yes, correct, Ramakrishna Reddy. It's not a permanent dipole moment. How many electrons does my oxygen require to complete its octet structure here? How many valence electrons are present in carbon dioxide, guys? In case of carbon dioxide, how many valence electrons are present in oxygen, in one individual oxygen? So again, two. Okay, 2 comma 2. Is it? Is it 2 comma 2? Please help me. Is it 2 comma 2? It requires two valence electrons. So how many electrons does my carbon require then? Yes, again, even then my carbon also has four valence. It requires four valence electrons. So all of these, the oxygen has two valency, and my carbon has four valency. Okay, thank you, Bhargav. Thank you, Tejas. Thank you, Namrata. Now, okay, we know this concept. So now, since my oxygen, which is electrophilic again, oxygen, right? Which is electrophilic again, guys? Which among carbon, oxygen, which is electrophilic? Okay, the oxygen is electrophilic, right? Oxygen is electrophilic. Now, if oxygen is electrophilic, if oxygen is electrophilic, so what happens? It attracts the electrons towards itself, right? All the electrons shared by carbon, all the electrons shared by carbon will be more closer towards oxygen than the carbon itself. All the electrons shared by carbon will be more closer to oxygen than carbon. So what can we conclude? We can conclude that there exists a net positive charge on the carbon. So there exists a positive charge on the carbon, and there exists a net negative charge on the oxygen. Yes, a slight negative charge on the oxygen and a slight positive charge on the carbon, right? Yes, guys, can I say this? Yes. So the carbon dioxide molecule has a dipole moment between oxygen and carbon atoms. There exists a slight negative charge on oxygen since it takes or it pushes or pulls the electrons towards itself, and the carbon gets a slight positive charge because it's giving away its electrons. See, you could see here the electron is being pulled towards the oxygen, right? So it's more closer towards oxygen and less closer to carbon atom. So what happens? There exists a difference in potential, or sorry, difference in charges. So oxygen gets a slight negative charge and carbon dioxide gets slight positive charge. Now guys, considering this, in which direction is my electric potential? Considering this, in which direction is my electric potential? Is it from carbon to oxygen or oxygen to carbon? Considering this, in which direction is my electric dipole moment? In which direction is my electric dipole moment, from oxygen to carbon or carbon to oxygen? Yes, from oxygen to carbon, right? So there exists a dipole moment P1 in this direction, and there exists a dipole moment P2 in this direction, right? Then what happens to my net dipole moment? So what happens to my net dipole moment? What is P net? What is P net? So there exists a partial dipole moment between oxygen and carbon in this direction. Similarly, there exists a partial dipole moment between oxygen and carbon in this direction. What is the net dipole moment on carbon? At center, what is the net dipole moment at center? Yes, my net dipole moment will be 0. So such dipoles where my net dipole moment, there exist two dipole moments between atoms, hence the net dipole moment at the center will be equals to 0. Such dipoles where it exhibits only a temporary dipole moment. Such atoms which exhibit, or such molecules which exhibit a temporary dipole moment is called as a non-polar dipole moment, or such atoms are called as non-polar molecules. Okay, guys. This I think you guys knew. Yes, I think this you guys knew in your 11th, right? Okay, next we have to derive an expression for electric field due to a dipole. Guys, try to, yeah. Okay, thanks for the confirmation, guys. So guys, let's try to, yes, correct Bhargav, correct Ramakrishna Reddy. So we have to derive an expression for electric field due to a dipole. So I want every one of you to take some time to derive an expression. So in this case, guys, I'll just give you an introduction in today's class. We'll derive this expression in tomorrow's class. Okay, we'll derive an expression for this in tomorrow's class. So guys, yeah. So yeah, what's happening here in this case, guys? What's happening here? In this case, we have two dipoles. So there exists a dipole. So in this case, we have a dipole. Say I have two charges of same magnitude separated by a distance of 2a, right? Separated by a distance of 2a from one of the charge to other charge. Distance between these two charges is 2a. It's fixed always. Next, so we know that there exists a dipole moment from minus charge, I mean minus q to plus q, right? Exists a dipole moment always from minus q to plus q. Now, because of these two charges at a point r, I'll consider a point r at this position at a separation of small r. So what I'll do, I will consider a point r at a separation of small r from one of from positive dipole. Okay, from this point, I'll consider the distance of small r. At this distance of small r, I have a test charge. Say, assume it's a test charge, or I have a point. Assume it. Okay, it's a point r. Now, what is the net electric field acting on this point because of these two dipoles or because of these two charges? How to solve this, guys? How can we solve this? We just discuss how can we solve this. How is the what is the idea to solve this? What do you think we can? How do you think we can solve this question, guys? How do you think we can solve here? So the hint is we should consider only one of the charges at a time. Say if I consider this is a test charge, there exists a test charge, then I should consider plus q and q for first calculation of electric field. Then we'll find the magnitude of electric field due to these two charges along this direction, E plus Q. Then we'll consider the negative charge and test charge at this point and find the electric field along this direction. Okay. Then what happens to the net electric field, guys? What happens to net electric field? E net or net electric field will be equals to E electric field due to a positive charge plus electric field due to the negative charge. So we need to add these two and we'll find the net electric field. Okay. So guys, I want everyone to solve this. Please take some time and solve this question. Come on, guys, please take some time and solve this question. Try to derive this expression. Try to derive the expression for this, guys. We'll discuss this in our next class anyway. So guys, if you have any doubts in any of the concepts we have taught so far, please let us know. Let me know. So hope everyone have solved your modules which is shared to you guys. And guys, did you find DPP2 anywhere? I think I uploaded, but I don't remember in which drive. I mean, I uploaded in a drive, the same drive where we have physics DPP. So I think you could check that. How many of you got that? I uploaded today, yes, in the morning. Please check that we have physics DPP in this folder, in a folder. Please check that, okay? So guys, any doubts so far? Any doubts in any of these concepts which you have learned? Yes. So guys, yep. I hope everyone have solved. Everyone have tried to solve. If an yep. Okay, no. Okay, cool. Thank you, Nisha. So guys, I hope everyone is trying to derive the expression for electric field. Please come prepared with the expression of electric field. Next class, we'll be discussing about how to solve the expression. I mean, we'll derive the expression. Okay, in our next class, we'll derive the expression. Once we derive, we'll check the conditions for that. So next, we'll solve some questions based on that. Then we'll derive an expression. So guys, try to find the electric field due to a dipole on two conditions. This is homework for you guys. Please try to revise this. Okay, try to find the electric field due to dipole. So we will be solving both of this situation. One is along the axis and one is along the equatorial point. Excuse me. So I guess yeah, everyone, I guess this is still in your CBSE syllabus, right? This expression or derivation is still in your CBSE syllabus, right? Yes or no? Okay. Yes. So this is very important derivation, guys. We'll discuss all of these in our next class. Okay, and try to solve some problems based on these questions. Okay. So cool, guys. Then I hope everyone is solving the problem. So the guys, we have to get this answer. Okay, the electric field due to a dipole due to this along the axis, the electric field along the axis should be this. E is equals to 2q 2p 2qa by 4 pi epsilon naught r cube. Okay, let's try to derive this expression, and let's meet again on Wednesday, right? We'll meet again on Wednesday. Okay, cool. Hope you like the class, guys. Yeah, then we'll meet again on which day? Wednesday. Till then, see you guys. So guys, again talking about homeworks, I had given you guys a homework up on how to complete your what's that I asked you guys to write take a short notes, right? How many of you tried to do that? All YouTubers and live guys. Okay, cool. Ramakrishna Reddy, you got this. Superb. Awesome, Ramakrishna Reddy. So guys, yeah, I asked you guys to write a short notes of your own up to electric potential. How many of you have done this, guys? Yes, jana ಮಾಡಿದ್ರಿ? Okay, Lakshmi Likita, correct. Cool. Awesome, guys. So we'll anyway derive this expression. Thanks, Lakshmi Likita and Ramakrishna Reddy for solving these. YouTubers and others, I hope you guys have solved this. In yeah, even the Zoom audience might have solved this. Yeah, awesome, guys. Then I will again derive this expression on Wednesday. So please make a note that whenever we have completed some concept, you guys will be directly going and completing your short notes. Okay. Please maintain a short notes for formulas and all contents which we are going to learn. So it will help you guys. It will help you. So if I'm making a short note, I'll also try to upload in Drive. What I used to do is in my regular class, I used to go make you write the short notes. I'll used to come to each and every student and check. So that was what it was happening in physical classes. But since we guys are separated in online class, that's not possible. But I hope guys, everyone would be still solving those. I mean, still solving all the DPPs, solve all DPPs, daily practice papers, and maintain short notes. Okay, this is one thing. Maintain short notes and revise daily. Revise daily. Okay, this is what we expect you guys to do. Please do these three things, and you would get good. I mean, you will appreciate your work. Okay, you will find fruitfulness after this. Okay, okay, guys. Then we'll meet again on Wednesday. Thank you for being here. Bye, 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 guys. Bye, YouTubers. Please keep on supporting. Thank you. Bye, guys.